Thank you very much. Thank you everyone for coming. And I want to especially thank our panelists for joining us from different parts of the world, from Berlin to California. So this is a very special panel for me personally, and for a lot of young scholars that I have met at different conferences. Everyone has been talking about, a lot of people have been talking about machine learning and its potential usage. And in management, in particular, we have seen that has been a recent increased number of publications and working papers with machine learning techniques in management research. So that's why we basically organized this panel with four scholars who are at different stages in their career, from full professors to someone who just joined as an assistant professor. So they are like working at different level with different techniques. So I will share the motivation in a couple of slides later. But let me introduce these four scholars. So again, Rita Katila, like, she doesn't need any introduction at all. Like, every one of us grew up with her paper while reading her papers in our PhD. So Rita is a professor at Stanford, and she has published in all the leading journals. And I do want to point out one of our latest papers in strategy science, actually, where she talks about enabling technologies, where she used a very cool matching method. And like, that paper to me shows like how up to date she is with the latest methods, and how much she cares about recent innovation. So next up, Florenta Theodoris. So she is an assistant professor at USC Marshall. Again, she has published in ASQ, Management Science, SMG, and all these leading journals, and she studies innovation. And for me, another interesting part of it is that she already published with machine learning methods. And when I actually try to write something about natural experiments, I actually look at her papers. So for younger scholars, I think she has very nice templates if you want to write about natural experiments. So her papers are very, very well written. And next up, Jorge Guzman, assistant professor at Columbia Business School. And again, he has been using machine learning techniques for a while now. He has very exciting presentation for us today. He has published in Science, Management Science, Restat, and all these leading journals. So, and again, Jorge has a very recent paper, actually. I think it came out early this month. Again, he used actually different kind of machine learning techniques. So I would definitely encourage younger scholars to check that paper out. And last but not least, Jamie Song. She just completed her PhD and joined ESMT Berlin. She has a very exciting pipeline and on entrepreneurship research. And I have met her at an SMS conference, and her work actually impressed me. So, which is why we invited her to this panel. So I really appreciate all of you joining us here. So we should have an exciting panel today. So just a brief introduction about me. I just completed my PhD in strategy from Ivy Business School, and I'm a postdoc. So I have dual affiliation with the Sloan Business School as well as the MIT AI Lab. And I tend to use machine learning techniques on machine learning related papers as part of my dissertation. I'm happy to chat about with you all in future. Thank you. And so the rise of machine learning, just briefly, we have a lot of data right now. There is an abundance of data in our field, text data and even image data, all sorts of data. And we also have a lot more tools now. We have, Python and R, and computer scientists and other social scientists, they have been developing those tools, and they're just basically giving them away. So there has been a massive diffusion of those technologies, which is why we're observing more and more papers. And it's not only in our field, economists, political scientists, sociologists. So together they have formed the rise, this computational social science. So there has been a rise of computational social science, where social scientists from different fields are coming together. They're building tools, they're pushing the boundaries. And what I have noticed, even computer scientists are actually citing some of the tools developed by these social scientists. And so this opens up a huge opportunity for us in our field. So one of the motivations for organizing this seminar was, So what I have noticed, we have been using topic modeling and similar methods for a while now. But there have been many other methods, like our panelists will present, like Florenta has already published one paper with a different kind of topic modeling, and she will present another version of it today. So basically, we wanted to push the boundaries a little bit with let's go beyond topic modeling and let's go beyond talking only about machine learning with predictions. Maybe we can think about also causal inference. So we hope to have a conversation after these 4 presentations. So these presentations are not meant to give you, you know, like a tutorial or something. These are like these projects, these authors, they have been working on these projects so that we can actually, they're going to illustrate us with how they're using those methods in their work and pushing the boundaries of entrepreneurship and strategy research. So, so we have a couple of topics today, topic modeling, a different version of topic modeling, and 2 presentations on word embedding, and Rita's paper on causal inference and machine learning. And so this is the order. First up, Florenta, and then Jamie, and then Jorge, and then Rita. And then I will start off with a couple of questions. After that, we will expect questions from the audience. So hope to have a vibrant session. Thank you. So I want now Florenta to start her presentation. Thank you.
Thank you so much, Noel. Let me share my screen here. Okay. I assume you all see here, that's the most used phrase on Zoom these days. Thank you so much, Noor, for organizing this. I highly encourage you all to check out Noor's work. It's really good. And kudos to him for pulling us all together to talk about this important topic that is dear to my heart as well. So Noor asked me to talk about the paper that is under review at SMJ right now. And I thought I would start with just a couple of slides that should set the stage for that paper and hopefully will help with the other presentations as well, just so we are all on the same page. So first of all, I just want to make sure that I present what's my framework when working on machine learning. So I work under the premise that machine learning is a prediction technology. I think everyone in this room is aware of that, but just want to make sure that we are all on the same page. So that being said, here's a slide that I usually include in my PhD class on methods on causal inference when I teach that class, which I think, again, should help set the stage for what I'm about to tell you. Usually in management research, since this is our focus, we're interested in causal inference, or at least I like to believe that we are interested in causal inference. And perhaps we get there through various correlational steps, but ultimately we should be interested in causal inference. So if we have to look at a simple model, in causal inference, we are interested in what vectors xi cause y, right? And we are all familiar with that. So how is prediction different from causal inference? In prediction, I want to highlight 2 aspects, which are labeled assisted machine learning, unassisted machine learning, and I want to take the magic out of that and explain what that means, again, so we are all on the same page. Assisted machine learning usually is preoccupied with understanding what xi attributes try to predict the y of interest. So I have an example in there, say y is blood pressure. We are interested to understand if age, gender, smoking, etc. predict y. This doesn't imply anything causal, it's just a correlation, but the focus of prediction models is interested to understand how we can fit the next data point into this particular model. Okay, so nothing to do with causality, it's just a correlation to fit the next data point. Now, we have also prediction that is not interested in any y, and this is what we label unassisted machine learning. This prediction is basically interested in understanding the structure of a data set, so a structure of a vector xi. And I have an example in here, say, or based on the previous shopping behavior, predict what will most likely be shopped in the next round. So what will be the next items of interest. What I'm going to focus on today with topic modeling is on this last part, okay? So unassisted machine learning, which is basically just a classification. Again, to take a bit more magic out of machine learning, my favorite pastime, take the magic out of stuff. It's important to note that when we look at estimation tools in general, some of these estimation tools can be used out of the box for both prediction and causal inference. So the old friend of ours, regression, actually can be used for both causal inference and prediction. So when we talk about machine learning, it's important to keep in mind it's not something completely new and just plopped out of the sky that we haven't heard about. But there are also other newer tools, and some of them are used just for prediction. And this is what topic modeling, my focus for today, it's residing. So when, at least in my experience, when we talk about let's bring machine learning in management research, the focus is somehow to either adapt or exploit the benefits of these tools that are meant just for prediction to enrich our goal, which is causal inference. Okay, so with that, here's the paper that Noor asked me to talk about. This is a methods paper that was informed by another paper that is already published in Organization Science. This particular one is co-authored with my PhD student, Gino Lu, a great guy. Make sure you follow his career. He will be on the job market in a year. And Jeff Furman, who does not need any introduction from BU and NBR. The paper is under review at SMJ and is available to share if you're all interested. So I'm not going to insist on a bunch of details, just give you the high level. What we are describing in this paper is a topic modeling algorithm called HDP, which is a more advanced version of the well-known LDA. And we propose to use this algorithm to map the knowledge space. When we talk about mapping the knowledge space, we basically want to map any information that is captured in your text documents. So any kind of information captured in your text documents. Our goal is to be able to capture movement and distance as covariates in causal analysis through having a mapping of the knowledge space. Okay, so our goal is ultimately to create covariates that can be used in empirical analysis. Our effort is very similar to those of PubMed and MAG, Microsoft Academic Graph, if you're familiar with those. It's just that it provides an open source, more flexible approach of categorizing the information in your text documents. We obviously share the algorithm. The algorithm can be applied to a variety of data, and we also provide an application to the entire USPTO patent corpus from 1976 to 2019, and we share that data as well. So what can one do with the algorithm that we present? Is answer a variety of research questions, and this is by no means an exhaustive list. It's a list that it's closer, I guess, to our research interests, but certainly the creativity of this group can come up with more research questions. I'm not going to read them out loud, but they basically have to do with attributes of innovation that impact the competitive behavior, entry, exit of firms, and trading of technologies, for example, in the market for technologies. Okay, so why focus on the topic modeling for mapping the knowledge space? Surely we have taxonomy, citation maps, keywords, and so on. I mean, scholars have not stayed idle so far, right, in measuring distance, search, and things like that. However, obviously, as individuals that work in this space, you know that there are various limitations. There are plenty of papers that highlight those limitations. So we propose that topic modeling can address some of those limitations. With that said, it's important to understand that we are not suggesting that the topic modeling approach is a universally better approach that's going to solve all our problems. It's a complementary approach to the existing ones that is going to have some benefits and also some disadvantages. So exactly what do? We exploit this HTTP topic modeling algorithm that's more an advanced version of the well-known LDA. By the way, as an aside, if you have a few minutes to take a look at our paper, we cite a nice review of the topic modeling literature written by a computer scientist that goes into a lot of detail to describe all these versions of topic modeling algorithms that each of one, again, has advantages and disadvantages. The advantage of the LDP one that we use is that it automatically determines the number of correct topics. And I'm happy to answer questions about what it means, correct topics, because it's not necessarily intuitive. But that's important for our purposes because it means we can highlight a consistent mapping of the knowledge base regarding what text we input into this algorithm. The algorithm takes any input text, which is one of the advantages of our approach. You can come up with any combinations you want of a paper trail of innovation. And we have some examples in there: patents, academic publication, 10K statements, and so on. And what we do is we modify this off-the-shelf algorithm to output information that is of interest to the management scholars, because keep in mind, the algorithm is intended for predictions. So otherwise, this information is not presented to the user. Okay, so how can we use this algorithm in research? We are excited by the possibility of using this algorithm in combining various data sources. So as you know, when we rely on taxonomies to create maps of the knowledge space, we are restricted to each bucket that is being assigned a categorization. So patents separately, academic publications separately, and so on. With our approach, one can combine creatively all the text data that is of interest for, say, a firm has academic publication, patents, 10K statements, and so on, and produce a mapping of the knowledge space to that combination. The algorithm can be applied to trace changes over any attributes. Your creativity is the limit. We are giving some examples in there over time, which is the most popular approach, but also by geographies or demographic attributes. And in the end, our goal with this is to generate covariates that can be used in causal inference analysis, such as HHI, Gini index, new knowledge areas per period, similarity, and things like that. What are the benefits of this algorithm? First of all, it captures changes in the knowledge space earlier than most other approaches, and this is a direct consequence of the logic of topic modeling that is meant to understand any and all patterns in the data, including the very emergent ones. Therefore, it also provides a more accurate measurement of distance in knowledge space, since we have a more granular categorization with weights and probabilities and all that good stuff. And at the same time, also a more accurate measurement of movement, right? Since we have a more, think of it as a map, right? The more details you have in the map, the better you are to measure distance and movement in the map, even small movement or emergent movements. And most importantly, or not most important, what a very important one, certainly not the last, it provides a lot of flexibility to be applied to a variety of data sets, which we think is very novel, since other categorizations, like I said, are restricted to particular data sets. Obviously, words of caution, because since we are with the perils of machine learning as well, and I'm almost done, I promise, it's not always the best approach. Don't think of topic modeling as coming in and sweeping away everything that we learned so far. That's not the case. Think of it as an additional tool in your toolbox and understand when you might need topic modeling and when you can make do with what we know. So this is a key to selecting the most appropriate empirical strategy. The fact that, say, diff and diff is popular doesn't mean it's the most appropriate all the time or whatnot, right? So keep in mind that this is not something computer science new, as in we are not reinventing the wheel. There are plenty of intelligent people that, Noor, I'm going over time.
Yes.
I'll stop.
Yeah.
This is not something C as new, but just adapted. And does not address concern with the text that is incorporated in your data set, right? So it's up to you, the researcher, to decide if your text is appropriate or not. Okay, so I'll show you just 2 seconds an application example. With this data set, we find that in pharma, for example, diversification is always overestimated with patents. The paper that Noor mentioned that is published in Organization Science was interested in understanding the impact of automating technologies on the direction of innovation. So we use HDP in the graphs above as a robustness measure for more classical measure, and we discuss differences in magnitude and slopes. Okay, so to conclude, not a substitute for existing measure, but it does provide a lot of benefits to answer a number of research questions that I'm happy to talk after that. I apologize for going over time. Thank you so much.
Thank you, Florinda. Now I would like to ask Jamie to start her presentation. Thank you.
Sounds good. Hi. Okay. Yeah, thank you, Nair, for inviting all of us and organizing this very exciting and relevant session where we can learn from each other. So thanks a lot for that. So my project is part of my dissertation chapter. I just graduated this summer, and this is basically looking at how entrepreneurs can frame their innovation to gain support from their audiences. And in doing so, I use a word embedding approach to create the measure of the frame alignment. So let me just start with an example that a lot of us are probably familiar with, which is Airbnb. So Airbnb first started in 2008 by a couple of designers who had this wacky idea of renting out a mattress in their loft. And as you can imagine, Airbnb initially really struggled to gain support from their external audiences, like the potential consumer of the innovation. So in these type of uncertainty, entrepreneurs play a very crucial role in shaping audiences' understanding of the innovation by engaging in communication with their audiences. So for instance, you see here that Brian Chesky, the CEO of Airbnb, is broadcasting his stories about Airbnb to influence and to gain support from their target audience. And now, in the age of digitization, social media and online community platforms have also dramatically increased the extent to which entrepreneurs can directly engage with their audience members. For instance, you see here that Elon Musk, who is usually very active on Twitter, is engaging with an audience member about Uber's aerial taxi back in the day. But what's different about this type of communication that is happening on online platform like Twitter is that now the communication is increasingly public. So the conversation is not just between the two people, but it could actually indirectly reach millions of other people who are observing the conversation. So as we can see from the previous example, entrepreneurs in public interactional domains like online platforms are not just engaging with one conversational partner, but they're increasingly using it as a platform to address a wider base of heterogeneous audiences who are observing the conversation and who may be the real audience. So in my paper, I study how entrepreneurs frame their innovations with respect to their conversational partner to gain support for their innovation from a wider and heterogeneous audience who may be observing the conversation. And before I dive into it, first of all, what do I mean by frames and what do I mean by framing? So according to prior literature, frames are schemata of interpretation that guide audience's attention to specific dimensions of interpretation. And according to this definition, frames can then be represented as the distribution of attention over different dimensions of understanding. So for instance, let's say that we take an X-ray of someone's frame regarding an innovation. On the right-hand side, we can see that this person puts a heavy attention on the data infrastructure aspect of innovation compared to other dimensions. So that's how the prior literature and I have thought about the notion of frame. And in terms of framing, it's a process through which actors use language to influence the attention allocation weight across different dimensions in someone's frame. And what does prior literature say about framing? So prior literature has found so far that frame alignment, so using the similar language and aligning with the frame of their audience is an effective strategy for gaining their support. So frame alignment leads to resonance with the audience's needs, interests, or beliefs, and similar frames also enable interpersonal coordination. So then going back to this microstructure, prior research would then predict that entrepreneurs will benefit from adopting the frame that is similar to those of the conversational partners that they are directly engaging with. However, entrepreneurs' framing effort could in fact indirectly influence a much broader audience, as stated earlier, especially in public interactional domains. And in these settings, frames that are used by conversational partners who self-select into conversation is also unlikely to be representative of the frame of the broader and more heterogeneous audience. So for example, prior literature has found that those who are vocal and those who select into conversation tend to be experts or they have strongly defined interest in the matter. On the other hand, the silent majority that choose to sit back and may be more ambivalent about the specific frame that's used to understand the innovation, or they may be interested in a different aspect of the innovation. Therefore, while prior literature has suggested that entrepreneurs would need to align with their conversational partners, I argue that frame alignment may in fact be detrimental if entrepreneurs' goal is to gain support from a wider group of heterogeneous audience who are not necessarily represented by the conversational partners. So I test my claims using massive conversational data on Product Hunt, which is an online platform for discovering the newest products. And a unique feature of this platform is that audience members engage in conversations, and they also vote on the products that they like. And I can observe all time-stamped interactions on this platform. And on this platform, gaining more upvotes is critical for the success of entrepreneurs' innovation because products are ranked based on their number of upvotes, and the top 5 products are distributed to the entire community, which also includes Silicon Valley influencers. And as for the empirical measure, support from the wider audience member that are observing the conversation is measured by the number of upvotes. And as for the construct on frame alignment and whether it is negatively influencing the audience support, to do that, I extrapolate frames based on the language that is used in the comment threads. So how do I do that? I use a relatively new machine learning method called word embedding. And what this does is it uses the neural networks to create a vector representation of words that people use based on their similarity in the contextual meaning. So for example, this is a simplified example of how word embedding is used. And according to prior methods like topic modeling, if both words did not appear together in the sentence, they would not be captured as words that are sharing similar meanings. So in the example here, the cryptocurrency in Bitcoin, they would not be captured as those that are sharing similar meanings, but word embedding vectorizes each word based on shared context. So in this case, even though these 2 words do not appear in the same sentence, they would be positioned nearby each other because they share similar context. And I believe this way of determining words' position based on their similarity in contextual meaning is good. First, because it can better deal with the polysemy of language by distinguishing the contextual usage of language. And second, I can capture the continuous relationship between words based on their meaning in a relatively short text. So using this approach, then the word embedding would generate a vector P representing the distribution of dimension in understanding the innovation, which is what I previously defined as frames. Words that reflect similar frames would be plotted nearby each other, whereas those that are sharing different meanings will be positioned further apart. So after capturing frames based on the use of their language, I measure frame alignment by calculating the similarity between the average frame that is used by the conversational partners and frames that are used by the entrepreneurs in their response. So just a quick addition. So it is not required for the goal of this paper to identify what the structure and characteristics of dimensions mean in a certain frame, because my construct is a distance measure. But in terms of validity of the measure, I thought it would be very good to know what these dimensions actually represent, rather than thinking of them as as an array of a number of different dimensions. So I combine word embedding and semantic network approaches to translate word embedding vectors into one-dimension network, so that I can identify the characteristics and the structures of frames that people use to understand innovation, so that it's not just a distance measure. And with this approach, word embedding, the words that are words that have similar meanings will be clustered together in the network space. And if we look at one cluster over here, we see words like Node.js, Redis, JavaScript, which is clearly an engineering frame. And through this qualitative approach of looking at different clusters of meanings that's used in these words, then I can capture to the characteristics of the dimensions that are used in a certain frame. So just as a quick result, so all of the models account for product, entrepreneur, category, fixed effects, and they include numerous controls for linguistic measures. And my results basically show that entrepreneurs' frame alignment is, in fact, negatively associated with the audience support for the innovation. And I also find that this main effect really depends on whether the frames of the conversational partners are representative of the frames of the wider audience who are observing the conversation. So I think I'm running out of time, and yeah, and as for the contribution, I think I contribute to the framing literature and the evaluation of innovation literature by looking at how these type of communication, in fact, influences the heterogeneous audience that are not necessarily involved in this framing process. And in terms of method, I think there is a great deal of progress that can be made using word embedding methodology and combining it with other types of methodology, like the semantic network structure, to actually advance and better understand what these type of methodologies actually yield in terms of the meaning of the dimensions and meaning of the frames that are represented by this methodology. Yeah, that is it. And if you have any questions, feel free to email me. Thank you.
Thank you, Jamie. Now I would like to request Jorge to start his presentation.
Okay, hi everybody. That was great. It was so cool that Jamie presented. I mean, the papers were awesome, but also she talked about word embeddings, which I also use in the way kind of look at similarity between speech. So there's methodologically, there's actually a lot of similarities between what she did and what I'm about to show. And I think that shows the kind of overlap in what we're after. I'm going to try to go through these rather quickly. This is a paper I have called Measuring Founding Strategy with Aishin Lee, who was at Columbia, but now is an incoming student at Tsinghua University. We're thinking about a pretty straightforward question, we think. How can we measure the founding strategy of startups and its relationship to follow-on performance? So that's kind of what we're thinking. And we start focusing on one version of definition of strategy, right? Which is this idea of differentiation. If you think about sort of what kind of Porter 1996, what is strategy? Competitive strategy is about being different. And so, you know, not only sort of conceptually different, but sort of different in creating a unique value proposition. Here's sort of two slogans for two companies, so you get a sense of what being different would mean. Southwest has a slogan that says low first, nothing to hide, that's transparency. And Delta has a slogan that says world's most trusted airline. And so it's pretty easy to see that there's, even in the airline industry, they're both selling flights. These two are kind of quite different, right? Southwest is about low cost and sort of looking for those sensitive customers, and Delta is about trust and coverage and that kind of thing. So, for example, Southwest tends to be late very often, and nonetheless, it's very profitable because it's not something its customers are optimizing against. Now, what I want you to think about, going back to this idea, competitive strategies about being different, is what would happen if I put in a third company with a slogan like Spirit, with a slogan, less money, more go? Well, somebody like you or me or sort of an analyst would pretty quickly pick the difference that less money, more go seems to be closer to what we were saying with Southwest. Less money, more go is also about kind of cost-sensitive customers, etc. So it would impinge, it would hurt the differentiation of Southwest more than Delta. Okay, this is sort of gives you a sense that as analysts, our humans, we're pretty good at kind of seeing what companies say and understanding that there's this conceptual map of kind of closeness or distance, and whoever's farther away in this conceptual distance is able to get some differentiation. What we're going to try to do in this paper, or what we do, is try to take that and kind of look for a systematic way to do it within machine learning and for startups. And so we bring in a couple of insights to be able to do that. The first insight, or sort of one of our key insights, is that rather than using these systematic slogans, there's one place that sort of over the last 15, 20 years, most companies, most reasonable companies of certain kind of quality are writing out what they're doing, and that is their website. And so rather than using their slogans, we might be able to use their websites, and websites are usually a marketing tool. And so if you're able to say, well, we can grab the text of the website, how far is it from other companies, we might be able to perform a similar approach and sort of get these sort of distance based on machine learning. So, okay, so that's what we're going to try to do. Just so you know, all the code that's here is also available online. bit.ly/measuring founding strategy. And we'll release the data as soon as the papers do. Okay, so first point that I told you, firms state their value proposition marketing statements. Second point, that I told you, there's this similarity in these marketing statements is a good indicator of the suitability between products. And third, you can get these from websites. Now, how would you measure this similarity? Well, you would do exactly what kind of Jamie did. You could do word embeddings, you could do other things. What she did is pretty much exactly what I did, which is sort of word embeddings is this natural language processing approach to develop sort of a vector representation of a text document. And if you do the cosine similarity between that, it tells you how close or far away is one sort of version of the text, in our case, a website, from the other website in kind of text space. And so we do the same thing and basically get this measure of how far or close is one website from a lot of other websites, including both. We're going to go not for only other websites that are kind of its peers, but also public companies. Now, let me take a kind of segue here and show you exactly the type of text we're working with. So, and to do that, we're going to go and work with the Internet Archive. Now, the Internet Archive, you may be familiar or not, it is a nonprofit whose main goal is to basically archive the internet, right? Create a historical version of the internet so you can always access it. And they have this tool called the Wayback Machine, which actually allows you to access these historical versions of websites. And so here's like Columbia EDU. You can see it's been snapshotted 14,600 times. Let me show you an example for Grubhub, right? So here's Grubhub. This is this Crunchbase page. It says it was founded in 2004. And so if I go to the Internet Archive, I can see that in 2004, it actually has quite a few snapshots. It has sort of one on August 5th, one on August 6th, one on August 9th. And this is, the one on August 9th, this is how it looks. And so this allows you to see, Grubhub is sort of similar to what it is today, but not quite. Today it's a delivery company of food. Back then it was more of a listing service and it was really locally focused around Chicago. And so, over time it grew to sort of be these, here's how it looked in 2012, and here's how it looked today. So what we're going to do is precisely this. We're going to look at this version of the website because we're thinking about founding strategy. So we're going to look at the founding version of the website around the founding time. And we're going to see how unique is this website compared to other websites from other startups, as well as sort of the existing market structure of the time. Other websites, we're not going to be able to look at all the industry, but what we're going to do is we're going to look at the websites of all the public companies also at that time. And so we're going to ask ourselves, what is this company doing compared to what everybody else seems to be doing at the time based on its marketing statements, or on its website kind of proxying their marketing statement. Okay, last thing. So I hope you get a sense of we're able to make this map of sort of the distance between, for example, every firm founded in 2004, how far away it is from a bunch of other companies. The last thing is how do you aggregate them to come into this measure that we call differentiation, right? That is sort of a version of founding strategy. And so basically, conceptually, when we talk about strategy, it's not sort of how far away you are from the random company. It's not how far away you are from all companies. It's really how far away you are from those closest competitors that are really hurting your kind of differentiation. And so, if you look at some of those classic papers like Bresnahan and Rees, they showed that this ability to kind of make an extra profit, it really evaporated once you get about 5 competitors. And Mishu Igami and Kosuke Uitake show that kind of competitive pressures change your behavior basically for the first 4 or 5 competitors. And so it's a bit ad hoc, but what we're going to do is really say, well, what is your average distance to your closest 5 competitors? Now, of course, Jamie showed us a way to measure similarity. So we just get the inverse of that 1 minus, and so we're going to get for each company how far away it is from your closest 5 competitors. If you're farther away, if the closest competitors from what you're selling compared to what others are selling, if the closest competitors are farther away, you're a more differentiated company, you might have more strategic differentiation, and we can see what that leads, how that predicts performance. Okay, so that's our measure. I hope that that was sort of a very quick overview. This is a couple of examples. Here's everything. We're using Crunchbase companies. So this is an example of companies that in Crunchbase are categorized as food companies, and you can see that at the top we have this company called Hika Chips, which is like jicama chips. It's it feels sort of innovative for these product space, compared to at the bottom, we have big box overstocks, which is sort of discounting and kind of not that level of differentiation. This is the description in Crunchbase. Here's a different area: consumer electronics. At the top, Perihug, Parable, Wi-Fi enabled teddy bear that lets you hug someone from anywhere in the world. Lark, the leading digital company using AI in clinical science. Whereas at the bottom of these differentiation scores, like cross-world warranty, kind of something to manage your warranties online. And so here's Perihug. It didn't succeed. Not all extremely differentiated products work great. So, okay, so that's the measure. Now, that's I think I'm about to run out of time, but just so you see how it predicts performance, here's the scatter plots. We do find that of course, there's a huge correlation between our measure. This is at founding and later on financing. A lot of it goes away when you include founding year fixed effects and when you include industry fixed effects. But it's still, we find these for example, if you look from the 0.15 to the 0.06, it's about 2/3 of the differences in about how firms relate to each other and performance are absorbed by industry. That's pretty consistent with most studies about how much does industry matter in profitability and that kind of thing. So we find that consistent with existing literature. We also, you can see it against other outcomes, Series A. And then the second thing we do is we look at equity outcomes, IPO being acquired. And there, let me skip over that. And then what we find is that the relationship is a lot noisier. And it turns out that consistent with what you would expect with a pretty differentiated product, here's the graph that I want to get to, right? Products that are very differentiated early on products that are very differentiated, or companies that are very differentiated, do not perform quickly, these equity outcomes. It takes them longer, as we know from disruptive technologies, to establish themselves in the market. But over time, they more than make up for these differential, and they're kind of over the long term more likely to succeed. So last thing we do, we look at how much is the statistical relevance of our measure, and we find that our measure predicts about 25% of the variation in outcomes on equity outcomes and about 21% of the variation in IPO or acquisition. And so that's kind of what we did. We're trying to measure founding strategy. We focused on one version, this idea of strategic differentiation. We used from the underlying concepts. We tried to bake it into machine learning. We try to develop these measures. They're validated against what you would expect differentiation would look like, but also it's a little bit formalizes what you would think. It does seem to reflect a lot of the variance in performance, and that's all I had. Last thing, we would release a lot of these data later. So once the paper is out, we'll release the text of the founding websites and the doc-to-deck models, the Untitled word embedding models, and measures of similarity, etc. So stay in the lookout for that. Thank you so much.
Thank you so much, Jorge. Now I would like to request Rita to start her presentation.
Hello, everybody. Great to see everybody, and thank you, Noor, for organizing this panel. Super exciting. So I was thinking, as others were presenting, I'm not as fast talker as Jorge is. That was amazing. I don't know, you're like 50 slides. That's amazing. But Florenta did set everything up very nicely for me. We're like the bookends of this session. So thank you, Noor, for organizing it in this sequence. So my job is a little bit easier. So what I try to do in the next 10 minutes of my time is to bring together Florenta's prediction and causal inference. So basically bringing together these two concepts that I think Florenta was saying, well, prediction is what machine learning can do well. I'm trying to convince you that what you're doing with causal inference these days, if you're using two-stage models, any kind of matching, you're actually using prediction more than you think. So machine learning becomes important for you if you're doing machine learning. So what I'm going to talk about is a project, couple of papers. So the strategy science paper is already out. And then the paper that I will highlight a little bit more today is working paper stage, or I guess, under review as SMJ as well as the same thing as Florence's paper. So the idea is, the headline is, how can machine learning help causal inference in strategy? So we went through presentations where machine learning was used to sort of kind of organize, understand vast of data, lots, huge amounts of data. So clustering, categorization, topic modeling, text analysis. In contrast, what we suggest here is machine learning is underutilized in deductive strategy studies, where supervised machine learning can often be used to improve causal explanation. So if you have self-selection in your models, as many of us do, machine learning can help. So that's the highlight of the presentation. I also wanted to mention these methods are very well researched and well established in economics, biostatistics, Embedding, FA. If you're following some of these names, they have wonderful papers. We are bringing these concepts to strategy. My co-authors are Jason Rathe. All of this work is based on Jason's dissertation. Jason is now with Air Force Ventures, and Phil Reinecke, a current PhD student at Stanford, has joined the team. So I want to motivate this a little bit similarly to what Jorge just did, but using a little bit different nuance on what strategy is. So if you look at Michael Leiblein's work, Levinthal, Porter, Sigal, Rivkin, they all talk about that strategy is about, at its core, about complex decision. So what does this definition of strategy mean? It means that underlying any major strategic decision, there's a number of factors that go into the decision, and that these factors are interdependent. So typically interdependency is across the firm's own contemporary decisions. So Porter and his students call these activity systems. The second point I want to make about strategy and definition of strategy is that research in strategy is fundamentally interested in performance implications of these decisions. So that's a definition of strategy. Now, when you put these two things together, complex factors underlying a strategy decision, and our interest as strategy scholars of trying to figure out the performance consequences of these decisions, we all know that problems arise for causal inference. So if you think about how we typically handle the problem of causal inference and self-selection, it's most often taken care of through yours and my intuition. And if you've done matching studies, for example, in the past couple of years, we tend to rely on our intuition as researchers of, picking a few attributes, firm age, firm geographical location, etc., and then we model self-selection using those attributes. So we're not suggesting we should replace the researcher's intuition about what goes into self-selection of companies, for example, into some strategies, but rather that machine learning can augment, can help here. So problem is, we don't know whether our intuition to pick a couple of variables, particular attributes, to determine choices of firms is right. And as several authors have said, the process of using a few ad hoc linear determinants doesn't really match, as we saw above, how we theorize about how strategic decisions are made, and probably not in reality how firms self-select into their decisions. So we tend to think about, if you think about fitness landscapes, we tend to think about these smooth, as we use our intuition, these smooth landscapes, while in reality, we're probably more towards the right, which is a spiky landscape. So what to do about this mismatch between theory, how we think about strategic decisions conceptually, and then how we are modeling, how we are empirically researching, and does it matter? Okay, so this is our working paper in the slide, in a slide on the left, research to date, and then what we suggest we should do to incorporate machine learning will be on the right. So first, the motivation. So strategy scholars emphasize complexity of strategic decisions in theory, as I just showed, this complexity that underlies choices is not implemented in empirics. So we explain why complexity matters for deductive strategy research, and then how machine learning can help. So that's the motivation. The problem and the solution. Problem is strategy studies often prone to treatment selection bias. The current quasi-experimental methods don't entirely solve this because we're using these ad hoc simple confounders. So on the right, we propose and unpack a novel machine learning matching method that allows for stronger causal inference. So again, it's not new. It's implemented in econ, in biostatistics, but we are bringing it to strategy. And very quickly, evidence is threefold. We did a meta-analysis of matching studies in strategy, show that this actually does matter. Many of us are using methods where machine learning could be really helpful. We conducted a simulation where we know the data generation process to show potential bias, and then how machine learning can decrease bias, and then have an empirical demonstration of how this method works and how it can actually sort of qualitatively change the observations and when we add the alternative methods. Now, just a little bit of motivation. So at this point, if you're not using matching, if you haven't used two-stage methods, not doing maybe even not quantitative research, you're maybe quite puzzled why all of a sudden you should believe Rita that strategy really needs these machine learning methods, especially in causal inference. So this may all sound niche and boutique, but matching methods, especially propensity score matching, are exploding in strategy. I just want to show this quickly to say, if we are giving, for example, public policy recommendations based on our studies, as many SMJ strategy science pieces are doing these days, we have really the obligation to get these models right, and machine learning can be helpful. Okay, what this meta-analysis shows that there are 3 ways in which machine learning can be helpful, and I'll be quick here because I know I'm running out of time and want to be respectful of everybody's time who came here today. So 3 areas that need attention. Untestability. So as I mentioned earlier, researchers, if we're left on their own devices, determining what kinds of confounders might be or might not be needed, we don't really know whether the researcher's intuition is right. Machine learning provides us metrics to see whether we have the right confounders. So ACU metrics is an example. Also, under and overfitting, so definitely a problem. Regularization, another machine learning technique that Jason's dissertation papers are using, definitely a tool that is helpful. And finally, when we have these complex decisions, machine learning also helps with computational intractability. So basically, you're running your models forever, so machine learning can help there as well. Okay, so we are suggesting that integrating machine learning into your toolkit, if you are more of a sort of a deductive strategy researcher, is going to be helpful. So that's the big headline. And Noor was mentioning a few papers in chat earlier. So this is a strategy science paper. If you're interested in how this is done in practice, we have sort of a very detailed review of the method in the paper. I also mentioned the simulation that we're doing, and also sort of an empirical demonstration, how adding machine learning methods, for example, to patent data, Tragenberg's classic study on patents, can really qualitatively change as we add more and more advanced methods, how we are interpreting the coefficients and different effects. Okay, so let me stop here and just summarize what we said. Motivation is these complex strategic decisions, and we are arguing machine learning can help also on the deductive side. We are proposing to bring from econ and other related fields a machine learning matching method specifically to help many researchers who are using two-stage types of methods in strategy today. And my big headline is that machine learning can, in fact, help in many ways. And that's where I want to end today, and excited again to be here, and over to Noor for some remaining questions.
Thank you so much. Excellent presentations, everyone. We had 4 exciting presentations, and I'm glad that Rita ended on a very positive note that machine learning can help. And in the chat, we can already see that there have been both very technical questions and questions about theories and like how to push management. Before we get to those questions, I want to mention that actually we can continue a bit more even after the 1 hour long session. So if you are interested, please stay on, and like we can still continue our conversation on that. So I want to start the Q&A session with a couple of questions that we basically promised in the abstract of our event. So I want to start with Florent and Jorge first about, what are the potential limitations of machine learning methods in our field? Or what do you think about the perils of machine learning method from your own experience as a reviewer, or as an author, or as a researcher? So Florent, if you could go first, thank you.
Sure, great question, Noel. And perils of machine learning, I mean, I'm sure there are plenty of them, but as I alluded in my presentation, I think one of the perils of machine learning is to forget what we've done before, and to forget the advantages and disadvantages of the methods that exist, and somehow believe that machine learning is the magic answer to all our problems, and switch to that. I view machine learning, as I said, as another tool in our toolbox. And it's important to understand what it does. So a second peril that I want to highlight is not understanding what machine learning does. And basically just having a very superficial understanding of what this technology is, and making lots of implicit assumptions about what it can do, and throwing it at the data, again, without a deep understanding of what it can do. No technology is magic, okay? I'll just leave it at that. Nothing is magic. There's a code behind it, there's a logic behind it, and no code or methodology is gonna squeeze something out of the data that is not there. There are assumptions in the code, so it's important to understand what the tools do, okay? So that's my 2 cents. Don't forget what we know, and understand what this new one does and what assumptions it makes.
Thank you. Jorge?
I think Florenta's points were the best. I just to think about, one example when she says it's not magic. I remember the old LDA papers 10 years ago. People thought topic modeling could just, now you knew everything. And, if we see it today, it's like a lot more complicated. And there was tons of judgment and some level of working paths in creating topics. And so that's certainly something that can happen as we keep applying these technologies. Maybe a second thing is that I think machine learning is so broadly powerful that I feel like you need more theory, not less theory, when you think about it, right? You need sort of very clear theoretical constructs, and then also understand very clearly how they map to all these kind of Python code. And then, so it takes, I think one obvious concern would be that, you could put machine learning into any text, for example, in the case we saw here. But then what does it even mean is going to be a challenge, and people can get sort of, you really need both, I think.
Jamie and Rita?
Yeah, I can just chime in about potential perils of like p-hacking, because there is so many parameters that is associated with a machine learning model. I think you have to be very structured ex ante training. What are the criteria that you're going to use, and have a very structured approach of like testing, and knowing that which parameters is actually the optimal one for your model. And ex post your training, also having a very structured approach of testing the validity of your training, and knowing whether this model is actually a reliable one to test your hypothesis. Because I think if not, it will be very easy for you to like adjust different parameters and like get different results. So I think I would be very cautious about p-hacking when using machine learning methodologies.
Thank you. Rita?
So I'm an engineer by training, and my colleagues do computational social science in the same department. So I could not be more excited about machine learning. I did want to add very, very good comments by everybody about sort of being cautious about what the method can do. You also asked earlier, what do the reviewers say? So perhaps my answer here is we've been pushed a lot by many of you in the audience, I think. Why don't you guys just use logistic regression as you predict the first stage? We actually ran the models, and it's really interesting. Turns out logistic regression, very simple method, does really well most of the time. So perhaps introduction of machine learning is not necessary at all. We do find a sweet spot, which I think is the most delightful and important news for strategy scholars. When we look at different data sets in terms of size, the sweet spot of machine learning where it really makes a difference and is better, more accurate than logistic regression is our data sets, which are around 1,000 observations. Many of us have done for years research, on 10 years of data on about 100 firms, longitudinal data set. That's where machine learning can actually help. So I leave it there, but I think there is lots of promise for strategy, but be careful, as everybody was saying.
Thank you, Rita. Next question, I want to be very brief here because we have a couple of questions in the Q&A. Your experience with the review process, what should be your suggestions to younger scholars or scholars who are just getting started with machine learning methods? Again, I want to start with Florenta because she has already published one and a couple of others are under review.
You're really trying to push my buttons. No, I'm joking. I'm joking. No, again, good question. It's hard. I'll say that. So it's hard to publish with machine learning, and that's not necessarily bad. So I would say this is not only advice for young scholars, but it's also advice for fellow reviewers. If we want the field to advance methodologically, we all need to invest some time and understand what these methods do. So I do, in my somewhat limited experience, that in publishing these papers, having a paper under review and reviewing for several journals in there, I do see issues on both sides in a way, in the sense that sometimes reviewers don't have a good grasp of what machine learning is. So they are unnecessarily harsh to the papers. And I do see the authors also not having a good grasp of these methodologies and just throwing machine learning at the data and their hands in the air and claiming that things are happening. So I think with time, we are all going to learn a bit more of what's going on and move forward. And just to end with an example related to topic modeling that I cannot emphasize enough, we call the topic modeling buckets generated categories. I've seen it time and time again of people just looking at those and thinking categories, same as in a taxonomy or same as a human being would come up with categories. It's not the exact same thing. So even small differences as understanding what a pattern in the data might be and what a category that a human being would define as being relevant or interesting for management research. There are subtle differences that can make or break a paper. In other words, miss creative nuances in the paper or overclaim for no reason, right? So anyway, that would be my plea. In time, we all need to learn more about these methodologies to actually, and fully agree with Rita, be excited about them because they enrich our work. Thank you.
Yeah, Jorge, and then Rita. Oh, I think you're muted.
Oh,
Sorry. Yeah, now we can hear you. Sorry. Yeah.
Okay. Yeah. No. So I think in the one paper I showed you that our reviewers really pushed us to think a lot about the methodological contribution, and I think in our case that made sense. I think initially we were sort of had a lot more sort of trying to do both things. For us, it was hard initially, and that's where we came from. From this impression that it had to be, you measure something, but then you had to put it on a causal question, else there was no paper. And we tried to do both, thinking machine learning was something new. And so I was personally very excited that the reviewers really wanted to both develop the methodology and a data set, that would accompany and improve the field. And so we sort of invested a lot more in that and left the other ones as, not just sort of validations, but more like comparative statics, which are, if, in a world of equilibrium, this is the relationships that you would think. And so, I had really, really good experience in that sense. But I think in our experience, it was a lot of the value we hope will also come out by releasing some of these, not just kind of doing something, but also creating the tools that would allow other researchers to kind of move quickly. And hopefully that is the contribution in this case to kind of our shared science or something like that.
Yeah, no, thank you. Yeah, open sourcing these codes would actually move the field forward, definitely. So Jamie and then Rita.
Yeah, I think specifically for like word embedding, but more for other methodologies in general, I think I got a sense that it can be considered as a big black box where you don't know, the reviewers don't know what each step, how each step has been processed and what are the dimensions that you claim to be as part of your frames and whatnot. And that's one of the reasons why I was working on this methodology to combine word embedding with the semantic network strategy to visualize and to actually provide which words actually provide explains some of the dimensions in the frame. So I think providing a lot of examples and providing what do these measures actually mean in real life and how does it measure the construct that I claim to measure. I think those are the important things, especially because there are so many things that go into this model.
Thank you, Jamie. Rita?
I would just add that it's exciting that we are again at the cutting edge of what is happening methodologically across multiple fields. And I feel like not much new has happened in strategy for a while. And I think this is absolutely one of the things we are rapidly catching up. Events like this are so important to get everybody educated, reviewers, the editors, ourselves. So it was fantastic to learn about everybody's work. So good job, strategy field. So going strong.
Yeah, thank you. Yeah, no, that sounds fair. Yeah. So anyone else wants to ask question, please, you can raise your hand and I will just give you the floor. I know Nagme Shibani, I hope I'm not mispronouncing the name, asked a question. Do you want to ask the question, Nagme? I don't know how to actually bring her in because this is a webinar.
In the meantime, Noor, do you mind if I add one more thing on reviewers?
Yes, sure, of course.
I think it's a plea to reviewers. Sometimes reviewers do take this attitude. Why do you need all these fancy and complicated things? But it's more a matter of learning the technology. I mean, regression is super complicated also, right? And like matrix multiplication, we're just all familiar with it. And so it's a plea to reviewers that if, there's nothing that complicated about machine learning. And I think it's just a matter of all of us going up the kind of.
Yeah, I definitely agree. Yeah. So another important point, as Nagme, I will call on you soon. I hope you were there to ask your specific question. So before I get to you, like one point I wanted to highlight the way, Rita has been very positive towards these new techniques in our field. And it seems like a lot of senior scholars are also interested in these techniques, and they're acting as editors and reviewers, like just like when we were trying to organize this. Our senior members from SMS, they were very open to this session. So it shows the field wants to move ahead, and they are trying their best to move the field forward. So it's very encouraging to see that. Yes, so Nagme, yeah, you can just ask your question. You can unmute yourself and ask the question. Or do you want me to ask your question? Okay, so to save time, I guess I'm going to ask her question. So her question is to Florenta, I think. In which other cases you can think of using your HTP method, I guess, in terms of empirics wise?
Okay. I'm not sure if I understand other in addition to what, but let me just say, maybe describe shortly what this does. So HTP, it's a topic modeling algorithm that reveals the underlying structure of an otherwise unstructured corpus of text. So the goal of this is to see patterns in data. So let's say that the researcher believes that 10K statements have some sort of an underlying information about a firm's narrative. HTP can help reveal whatever patterns are hidden in those 10K statements. Jorge does a similar thing. He's looking at the strategy, he's trying to reveal the strategy of firms based on some narrative that the firms put out there on their websites, right? So HTP is another NLP tool, natural language processing tool. Natural language processing is full of all sorts of tools that basically build on top of each other, and they're trying to address various limitations of some others. What HTP's advantage is that it's basically hands-free, let me put it this way, from the user. You just press a button and it reveals the underlying structure, and then you can go from there. So from that perspective, it requires less tinkering than the LDA, and it gives richer information than clustering methods. In general, topic modeling gives richer information, so that's by construction. So Jorge's paper, for example, is a great example when you can use that, where we use it in the worksite paper, or anything that you can imagine that you're interested to see what's the information captured in text documents, even for what Rita is proposing, which is a brilliant way of using machine learning, right? When we do matching methods, we are just focused on observable characteristics, and observable characteristics are covariates that we can easily measure in the data. You can imagine using HTP to come up with other covariates that are otherwise unobservable in the sense that they are not readily available in quantified columns in your data set, but you can construct measures that are hidden somewhere in the text data and use them in the matching technique. So I don't know, I think there's, again, creativity is your limit where it can be used. I hope that helps. I'm not really sure. I'm happy to talk on the side, if that doesn't help.
Yeah. So I want to be mindful of the time and respect everyone's time. And I want to wrap up. And if you have other questions, feel free to reach out to me and to the panelists. They have been very kind and generous with their time. And thank you so much, everyone, for being here. I want to thank all the 4 panelists for your time, for your exciting work. And I also want to thank Robin for helping out with the whole process. I want to thank Colin and Elena with the whole process so that we could organize and have this exciting session. Let's stay in touch, and thank you very much for your time, and have a great one.